Right, I'm going to try and do this on one video, so you might have to pause it a bit in places. Just be careful with logarithms, they don't combine like normal numbers. And if you don't follow the rules, it will be wrong. So you have to be very pedantic. So, first rule is that log to the base a. This means the base can be anything. Remember, that's the base of your power of xy. So you could sort of imagine, I wouldn't actually write it in, but you could sort of imagine there's brackets around there. Is log base a of x plus log base a of y. So e.g., if you have log to the base 7 of 12, 12 is 3 times 4, so that's the same as log to the base 7 of 3 plus log to the base 7 of 4. Proof over here. Don't worry about the proof unless you want to worry about it. And if you don't quite understand it, let me know and I'll go over it with you. So I'm going to let P equal log x, Q equal log y, and then we can rewrite these as powers. So my base is A, the power is P. So A to the power P is equal to x, and similarly, A to the power of Q is equal to y. So if I multiply these two together now, then xy is equal to a to the power of p times a to the power of q. As long as the base is the same, when you multiply you can add your powers, so you all know that. So that's a to the power of p plus q. So if I rewrite this as a logarithm, log to the base a of xy is equal to p plus q. So that's using what we did on the last video, just rewriting the power as a log. And p plus q, p is log to the base a of x, and q is log to the base a of y. I'll go over some examples with these in a minute, so this is just going over the laws. So that's your first one. Second one is log to the base a of x over y is log to the base a of x minus log to the base a of y. And the proof is very similar. So we're going to use the same p's and q's as I did for the first one, but instead we're going to think about x over y, which is equal to a to the power p divided by a to the power q, and as long as the base is the same, when you divide you subtract, and then I can rewrite that one as a logarithm. So log to the base a of x over y equals p minus q. So that's rewriting this power as a logarithm, and p is log to the base a of x minus q, which is log to the base a of y. So when you divide, you subtract. It's because you subtract indices on division. So e.g., this is just a random example. So if you had log to the base 3 of 2/5, that's equal to log to the base 3 of 2 minus log to the base 3 of 5. That one. Third rule is that log to the base a of x to the power of n. So again, you wouldn't write this with brackets, but the brackets are sitting like that, essentially. So you're not, yeah, it's not around the outside of that. It's n log x. So as an example, I'll do the proof as well. If you've got log to the base 10 of 4 cubed, that's the same as 3 log to the base 10 of 4. So this power comes down and multiplies. And the proof along a similar vein as the other two is that x to the power of n, x remember is a to the power p. So we're raising that to the power of n. When you do a power to a power, you multiply. And so log to the base a of x to the n equals this power, np. But p is log to the base a of x. So they're quite nice little proofs. So that's the proof of that. If that's confusing in any way, please tell me and I'll go over it with you. Or you can rote learn it. So we've got these 3 laws, along with the one we did on the last video. And then just a couple of little notes, or 3 notes really. So the first one is that a to the power 0 is 1, which you should know. Which, remember, a is a positive constant for these. So log to the base a of 1 is equal to 0. So that's just rewriting this power as a logarithm. So whatever your base is, log of 1, I could have written anything in there, log 1 equals 0. Second little note is that a to the power 1 is a, which you know. So if I rewrite that as a logarithm, log to the base a of a, so a to the power 1 is a. So as long as these two are the same, you will always get 1. So for instance, log to the power base 5 of 5 is 1. And the third one to note is that if you've got log to the base a of 1 over x, that's equal to log to the base a of 1 minus log to the base a of x. That's our second law. And so log to the base a of 1 over x, log 1 is 0, so that's equal to minus log to the base a of x. Or you could write that as x to the power minus 1 and then pull the power over. But just sometimes you'll see these fractions as being rewritten. So it's worth kind of staying aware of those things that result from the laws of logarithms. So e.g., sorry, my colour coding is gone. So log to the base 8 of 1 over 5 equals minus log to the base 8 of 5. And then don't forget the very, very first thing we did on logarithms, that if a to the power b is equal to c, this is our definition of a logarithm. Log to the base a of c is equal to b. So that's the one from the first video. I'll do some work with some examples on the next, and then it should all sort of sink in a little bit more.